Every now and then a document pops up online that just feels different. It reads less like an engineering plan and more like something pulled straight out of a sci-fi epic. And that's exactly what we're digging into today.
Now that quote, "Wormhole, stand by," that's not from some Hollywood blockbuster. Nope, that's the actual system status you'd see on the control panel for a machine detailed in this massive, incredibly thorough, and completely open source engineering document.
So let's just dive right in, shall we? We're going to break down what this thing actually is. And for this explainer, we're setting aside the whole "how much would this cost" question. We're focusing purely on the science, the physics, and, frankly, the mind-bending engineering challenges that these plans lay out.
And right off the bat, here's the first detail that just grabs you. The classification? Open source, public domain. Think about that for a second. The creators have put everything out there for the whole world to see. It's this incredible what-if scenario, because in theory, anyone with the right team and, well, a lot of resources could actually try to build it.
Okay, so if you're going to start a revolution, where do you begin? The blueprints lay out this grand vision, and the first step, well, it's a huge one. It really all boils down to this one fundamental question, right? If you wanted to build a machine that could potentially manipulate space-time itself, how would you even start? What's step one? And the answer the blueprints give is, well, it's both simple and absolutely staggering. You start by building a star. Seriously, the plan is to create and contain a core of ultra-hot plasma. We're talking about a miniature man-made sun.
And when I say hot, I mean hot. The target temperature is 100 million Kelvin. To put that into perspective for you, that is way, way hotter than the core of our actual sun. It's just an insane amount of energy packed into one tiny space.
Okay, so the obvious next question is, how in the world do you hold something that hot? You can't just put it in a box. The solution here is something called a toroidal chamber. Just picture a donut-shaped vacuum. It's got an inner wall of super pure fused silica and an outer shell of stainless steel. And the whole point is to hold that plasma without it ever touching the sides.
So the bottle isn't made of metal, not really. It's magnetic. The blueprints call for a crazy powerful 8 Tesla magnetic field. This field, generated by 12 superconducting coils, is what actually traps and levitates the plasma. And if that concept rings a bell, it should. It's the same basic idea used in real-world fusion reactors like tokamaks.
All right, so we've got a star in a bottle. That alone is an incredible achievement, right? But believe it or not, that's just the beginning. This is where the design goes from, wow, that's really hard, to, wait, is that even possible?
Okay, check this out. Wrapped around that plasma core are 7 nested shells. Think of those Russian Matryoshka dolls, one inside the other. But here's the twist. They're designed to counter-rotate, and each one spins 3 times faster than the one before it. As you can imagine, by the time you get to that outer shell, the speed is just astronomical.
We're talking nearly 20,000 rotations a second. At that speed, the very edge of the outermost shell is screaming along at over 563,000 meters per second. That's a fraction of the speed of light, about 0.188% to be exact. Just wild.
Now think about the forces involved here. The centripetal acceleration, it's 7.1 billion Gs, 7.1 billion times the pole of Earth's gravity. And the document is super clear about this. There is no material known to man, not even the fancy carbon fiber they specify, that could handle that. It would just disintegrate instantly. And here's the best part. The blueprint's own analysis says the exact same thing. It flat out states mechanical rotation is impossible.
So you're reading this thinking, okay, it's a dead end, right? The whole idea falls apart. But then they pull out this incredibly clever solution. Here's the trick. The physical shells, they don't actually spin that fast. They can't. Instead, it's a precisely controlled electromagnetic field that's rotating. So you get the effect of that impossible rotation, but the actual physical matter isn't being torn apart by G-forces. It's a total game changer, just a brilliant way to sidestep a problem that seems impossible. Okay, so that's the how. It's a clever workaround. But now for the big question. Why? What's the point of all these nested electromagnetically rotating fields? This is where we get to the heart of how this whole drive is supposed to work. The core idea is something called parametric amplification. The best way to picture it is to think about pushing someone on a swing. You don't just shove randomly, right? You time your pushes to match the swing's rhythm. With each perfectly timed push, the swing goes higher and higher. It's the same idea here. Each shell pushes the next one at exactly the right frequency, and the energy just builds and builds, creating this massive cascade flowing from the inside out. And this is where the precision is just critical. The frequency of each shell has to be an exact multiple of the one before it. It's not just a random number. It's designed to create a perfect harmonic resonance. You know how if you strike one tuning fork, another one nearby with the same frequency will start to vibrate on its own? It's like that, but on a massive scale, allowing for this super efficient transfer and amplification of energy. Now, working alongside those shells are two other really key systems. First, you've got this emitter array, shaped like a flower of life, which is all about forming the energy into very specific geometric patterns. But then there's the second system. And okay, this is where we take a big leap into the theoretical. It's something called fractal Casimir cavities. The idea here is that these are designed to interact with the quantum vacuum, what's also called zero-point energy. It's the energy that exists in literally empty space, and the goal is to actually tap into and amplify that. So yeah, we're talking about sacred geometry and tapping the energy of empty space. It's really easy to feel like we've floated off into pure science fiction here, but what's so fascinating about these blueprints is that they keep yanking you back to the practical reality of, actually building and running the thing. And here is a perfect example of that reality check, the power draw. To get this machine up and running, it needs about 1.45 megawatts. Now don't get me wrong, that's a lot of juice, about what a small factory might use. But it's not some impossible sci-fi number. It's a real, concrete, achievable figure, sitting right there in the middle of all these wild, exotic concepts. And it doesn't stop there. The document even includes a full-blown project timeline. I mean, it's all laid out. Design and procurement, fabrication, installation, testing, the whole shebang. They estimate the whole thing would take 42 months. That's 3.5 years from start to finish. This isn't just some vague concept. It's presented as a real, manageable project plan. Which all leads up to this final, incredibly bold statement from the authors. Right at the end of the document, they put it in all caps, just to make sure you get the message. They say, with what feels like total confidence, this is buildable, this is real, this is not science fiction. And that just leaves us with this huge, provocative question. Look, whether this specific machine would actually work, that's a whole other debate. But forget that for a second. What does it mean for our world when a blueprint for something that could be world-changing is just released, put out there for anyone to download, to pick apart, and maybe, just maybe, to try and build? What happens next?